Greetings everyone, and welcome to Omicron IoT Solutions. Today, we'll be diving into the world of cutting-edge Internet of Things technology with the unboxing of the programmable IoT controller Controlog. This device allows for remote and real-time control and monitoring of different processes with high security and precision requirements, securely transmitting the data via Sigfox, LoRaWAN, or Wi-Fi networks. Adapted to your application, the Controlog can be easily used with the built-in code after installation, or it is possible to develop and use custom code based on the Omicron IoT Solutions developed libraries. There are two models of the Controlog device, designated by the names Controlog 9.3 and Controlog 9.2. The Controlog 9.3 has output number 5, which is analog, from 4 to 20 mA, while for the Controlog 9.2, all the outputs are relay type. In both cases, built-in visual and audible alarms are incorporated, as well as remotely visible alarms on the mobile or web application. On top of the box you can find the QR code that will direct you to the Controlog web repository. There, you will be able to access the technical documentation, general support information, and the libraries and examples to develop your custom codes. Upon opening the box, we are greeted by the Controlog itself. As a customizable device, a wide variety of accessories can be ordered to best suit your application. You can also order the different expansion or connection modules. Some of these include the 8-input expansion module to receive a larger number of signals, and the connection modules for current or voltage signals that facilitate the signal's reading. In addition, a 4.3-inch full-color LCD touchscreen can be ordered for on-site configuration and monitoring. As you can see, the Controlog has many ports. Let's see in detail what each one does. We can see the numerous inputs and relay-type control outputs available, as well as ports for measuring current, battery, and a Modbus RS485 port. Additionally, we have the ground ports, AC line inputs, and a 12V power supply. To connect the antenna, just screw it in place. Once you have selected the peripheral to connect, find the appropriate terminal. For this example, we are using the voltage reading module. Therefore, we need to use the S1, S2, and GND ports. To connect peripherals, simply use a small screwdriver to open the ports, insert the end of the cable, and close the port to lock it in place. Now, we will connect it to see some of its functions and its operation through the screen. These functions are also available without the screen through remote commands. For the HMI display, the supplied network cable can be used. Just connect it to both ends. After the loading screen, we will see the inputs. There we can change the names, icons, units, date and time, visualize the outputs, a graph of the readings, and access the configurations. Detailed information of the configuration options is provided in the user's manual and will be covered in a separate video. Now, let's see the Controlog in action. For this example, we will be simulating an oven heating action. Here we have an NTC, which is a temperature sensor and will be connected to input 1. The light bulb will be representing the heating action of the oven. Therefore, if the light is on, this means heating. We can assign the name, icon, and units based on our type of sensor. Then, we can assign the respective configuration parameters, such as type of sensor, offset, slope, and alarm limits. For this case, we are using a sensor type 4, NTC, a slope of 1, a small offset, and an alarm upper limit of 32 degrees. Now, moving to the Outputs tab, we can configure the control parameters. In this case, we are using output number 1, associated to input number 1. For our control parameters, we're using a set point of 30 degrees, an hysteresis of 2, and a timer on and off of 10 and 2 seconds respectively. The hysteresis will be the range where it will switch based on the control function trying to keep the value around the set point. As we're using a PID control function, we can adjust the controller parameters as shown. Now, let's connect the light bulb. As we're below the set point, it will turn on immediately. As the sensor reads a higher temperature, it will start switching the relay as it gets inside the hysteresis range. You can see how it turns on and off, trying to reach and stay the closest possible to the set point based on the internal calculations being performed. Once the reading is above the set point, it won't activate the light bulb as heating is no longer needed. As soon as the reading crosses the alarm upper limit previously defined as 32 degrees, it will trigger an alarm both locally and through the remote platform. Now, the temperature will decrease as the heat source has been separated from the NTC. Now that the reading is about to cross the set point, it will start switching the relay the same way, trying to keep the value stable. This will remain as long as the reading is inside the hysteresis range. If it goes even lower, the heating action will be continuous. Now you have seen the ControLog in action. Make sure to follow our channels to learn more about the ControLog, follow our other videos, and discover more about Omicron IoT solutions, our devices, and how to impact your business and the industry through the IoT.